Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video, we're going to look at part 2 of the transformations of periodic functions. So in the last video, we took a look at stretches and compressions. So in this one, we're going to complete our transformations and look at reflections and translations. So let's start with reflections. So in a reflection, let's say we have y is equal to, well, let's say we have this one. So y is equal to a sine kx. And of course, it doesn't really matter whether you're using sine or cosine. These same rules apply to both. So if a is less than 0, basically if a is negative, then it's reflected on the x-axis. Okay? And if k is less than 0, then it's reflected on the y-axis. Okay? So those are reflections on a nutshell. Let's take a look at translations. So obviously there are vertical and horizontal translations. So let's say we're taking a look at, let's look at both cases here. So let's go vertical first. So if we have vertical, let's say you're working with y is equal to sine x plus c, or cos x plus c. Okay, so what I'm going to do here is I'm going to split this in half. So I'm going to put vertical there, I'm going to put horizontal here. I wanted you guys to see the differences that you could see here. So when we have horizontal translations, we have y is equal to sine, but now inside the x you have x minus d, or y is equal to cos x in brackets minus d. Okay, so let's take a look at how our rules apply here. So if, for instance, c is greater than 0, this means my graph is moving upwards. So there's a vertical translation up by c. Okay? Basically, that means my graph is going up. If c is less than 0, then we have a vertical translation. Notice the language. Down by c. Okay? Now you can say c units if you want. This is more accurate, actually. So how does this compare in this situation here? Well, if d, in this case, is less than 0, meaning it's a negative number, then you have a horizontal translation either to the left or the right. In this case, it's to the left. Okay? And finally, if d is greater than 0, then you have a horizontal translation to the right. To the left, to the left, to the right, to the right. Yes, my bad singing is back. I am sorry. Alrighty, so let's take a look at how this works in examples. Alright, so let's take a look at some examples here. So for each of the following, I want you to describe the transformations, sketch the graph of one cycle, state the period, amplitude, max, min, the main range of one cycle. Okay? So, first and foremost, let's describe what is happening here. So, in this case here, we have a vertical stretch. So remember, let's get in the habit of identifying my important stuff. So that's 1, that's 2, so there's 2 transformations here. So I know that there's going to be a vertical stretch by a factor of 2. Now this plus 2 is outside, not with my x. So I know there's going to be a vertical translation up by 2. I'm using short form here, but obviously when you guys are doing assignments and tests, you want to make sure that you're writing the full out words. Just doing this so I can have room to write. So let's do our graph. So in our graph here, I know that what's my maximum. So first and foremost, this also happens to be my amplitude. Okay. And of course, because you don't see otherwise, I don't see anything here beside my x. I just don't see a k, so I assume the k is 1. So if the k is 1, this means my period. So my amplitude is 2. My period would be 360 degrees. Okay? So how would I find my max? Well, I know my amplitude is 2. And from there, with the amplitude of 2, and I know that it goes up to 360, so maximum, 360. Okay, and if you want to divide this in 4, that means you're going in these 4 segments, 90, 180, 270, okay? Alright, it kind of looks very messy there, sorry. Alright, so this is a cosine graph, so remember you start from your maximum in a cosine graph. And the amplitude is 2, and I went up by 2. So if the amplitude is 2, this means I should be starting at 2. But because of the vertical translation, I went up another 2. So that should be my maximum. So my max is 4. Okay? Now remember, in a normal cosine graph, you usually your minimum is -1. That's not the case here. It went up by 2. So because it went up by 2, you should be at this one right here. It should be at 0. 0 should be your minimum. Okay. So 0 is my minimum, 4 is my max. Okay, obviously my axis here would be at y is equal to 2, because that's always going to be what your axis is. Let's do this in red. I want to draw one cycle, and remember, when we're drawing our cycles, you want to start from your first 0, then your max, then your next 0, then your min, and then your third 0. But for cosine, you flip that. So you start from your max, then you go to your 0, okay, so you start from your max, then you go to your 0. So I want to cover this here at 90 degrees. I should be here. And this is going to be symmetrical, so at 270 I should be there too. So start from U, go down, that's my minimum, go up, cross this, and I should have my maximum at 360 degrees. And finally, my domain and range. Well, my domain goes from my minimum to my max, so what's my smallest? My smallest is 0. What's my biggest? 360. Range. What's my smallest? 0. What's my biggest? 4. And that's it. That's how you do A. So I want you guys to pause and try to do B and C yourselves, and then come back and see if you're right. Okay, I assumed you guys paused. Now you're back. Great. So this is what you should be finding in B and C. Well, 0.5 is important, and the plus 90 is important. What's the 0.5 say? Well, that's the same thing as saying 1/2. So that is a vertical compression by 0.5. What about the plus 90 degrees? The plus 90 degrees, well, I see a plus there. Now remember, my original formula had x minus d. So the fact that there is a plus here means that this number had to have been negative originally, which means d is less than 0. And if d is less than 0, this means I am moving to the left. So horizontal translation to the left. All right, let's do our graph. All right, so in my graph here, I'm going to have, all right, let's put my important points. So obviously my period here, again, I don't have a k value, so I assume my k is 1. So my period is 360. My amplitude is 0.5, or I can say 1/2. Okay, I'm not going up or down, which means my max is going to be 0.5. My max and my min would be 0.5, negative 0.5. So negative 0.5, 0.5. I know the period is 360, so I'm going to go with my normal separation here. Let's expand this bit. All right. Easy peasy. We got our max, we got our min. We know where it's going, so let's do it. Let's connect. So remember, this is a sine function here, so the sine starts at the 0. Then goes to the max. Okay? Now, here's the thing. We had moved to the left. And because I moved to the left, I would not be starting where I normally would be starting. Normally I would be starting at the 90 degrees, or the 0. But because I'm going to the left by 90, I should be starting at negative 90 degrees. So at negative 90 degrees, this is where I should have my first 0. Okay? Then at 0, I'll have my max. At 90, I should have my next 0. At 180, I should have my minimum. and at 270 I should have my next 0. And just like that, we have finished one cycle. Okay, domain and range, well, D, remember you go from your smallest to your biggest, so negative 90 degrees to 270. And for the range, I went from negative 0.5 to 0.5, so that's it. Let's take a look at C. So at C, I have a negative and a 2, so these give me two different things. 0.5x minus 180 minus 1. So I have 1, 2, 3, 4, 5 transformations here. So, what does this give me? So one thing you could do to make this a little easier on yourself is to actually factor out the 0.5 inside the graph. So here you can actually factor out the 0.5. And what would that leave me with? That would leave me with x minus 360 degrees, minus 1. So what transformations do I have here? Well, I've got definitely a reflection. So this is a reflection on what? The x-axis. Two, I have that 2. That's a vertical stretch by a factor of 2. 3, 0.5, this would be a horizontal stretch by, well, you know, 0.5 is the same thing as saying 1/2, so reciprocal of that by 2. Minus 360, which means next one here would be what? Next one here would be a shift to the right by 360. And finally, I've got this little guy here, which means I have a vertical translation down by 1. Okay, I'm going to continue this part in the next page so we can have some room here. So continuing C, I know my period. Remember my period, you do 360 divided by k. My k is 0.5. So this would give me 720. My amplitude is 2, not negative 2, 2. So that means my max, and of course I'm going down by 1. So because I'm going down by 1, instead of having a maximum of 2, I would have a max of 1. And instead of having a minimum of negative 2, I should have a minimum of negative 3. Because remember, we're shifting everything down by 1. So let's draw this. So, you know, the biggest it should be is 720. I also know that I am going 720 degrees in total. But I also know that I went to the right by 360. Okay, so if all in all I should have 360, that means you're going to start from negative 360. So I can go like this. negative 90, negative 180, negative 270, negative 360. And same thing on this side. 90, 180, 270, 360. So 360 plus 360, that's 720. So that's the length of one of my cycles. All right. I also know that my axis equation should be y is equal to negative 1 because I went down by negative 1. And also, if you do your max minus min, you should be able to find that stuff in max plus min divided by 2. All right, so what other information do I need? Well, that's just a matter of how you then draw it. So we're going to start from the negative 360. And remember, starting from the negative 360, we're talking about a sine here. So because we're talking about a sine, we usually start from the 0. And then we go upside down. And now remember, we usually start from the 0 but we have a reflection here. So because we have a reflection, everything is flipped upside down. So because we're flipped upside down, by the time I get to this negative 180, I should be at my minimum, which should be negative 3. And my max was 1. Okay. So I should be right here at negative 180. All right. By the time I get up here, I should be at this negative 1. When's the next time I should be at a 0? 90. Okay, and then at 180, I should be at my maximum. And finally, let's complete it. By the time I get to 360, I should be right back to where we began. And that's my full graph. So domain. What's my smallest? Well, my smallest is negative 360. What's my biggest? Positive 360. Range, smallest, negative 3. Biggest, 1. And just like that, you're done now. Take a look at one more example, and this one we're going to be looking at how you would be finding it from a graph. All right, so let's take a look at the second example. In this example, you're given a graph, and you want to find the equation of the graph of this sine function. So I usually would tell you if it's sine or cosine because this does impact which formula you would make. All right, so when you're doing these kind of things, you want to identify your key stuff. Like, what's my max? Well, my max is right here. That's a 4. My min, my smallest point. These are my smallest points. So at 0, well, it's my amplitude. Well, you can use your equation or you can use your eyes there, but essentially, amplitude, remember, is max minus min divided by 2. It should be 2. And my axis equation, same thing, but you add instead. So it's also going to be 2, which means my axis should be at 2 here. Great. So my amplitude's 2, my max is 4, my min is 0. What about my period? Well, my period, how would I find this? Well, I see in my period I'm going to 360. And if it's going to 360, this basically means k is 1. Because 360 divided by 1 is 360. So if k is 1, does that give me everything I need to solve this? No, because there is an obvious shift going on here, a horizontal shift. So how do I figure that out? Well, let's take a look. Each point, if this is a sine function, remember, a sine function should mean that at 0, I should be at 0. That's not happening. When am I actually at 0? All the way here. All the way here. So I'm actually at 0 here at 90. I'm at 0 here at 270. I'm at 0 again all the way around here. So there seems to have been a shift by about 180 degrees. As for whether this is to the left or to the right, you can definitely see it's going to the right. Because everything, I should be starting there. Instead, I went all the way here before I got a 0. And the next time I got a 0 was all the way over here. And over here, I have a 0. The next time I had a 0 was all the way over here. So 270 minus 90, 20. So definitely a shift to the right by 180. So with all this in mind, my equation therefore should be y is equal to, put my amplitude, which is 2. I know it's a sine function. I know it's going to the right by 180, so this should be still negative. And I'm going up by 2. How do I know I'm going up by 2? Well, amplitude, I actually didn't talk about that. My amplitude is 2, which means my max and min should be 2 and negative 2. That is not indeed the case here. Here you can see my maximum is at 4, and my minimum is at 0. So instead of being at 2 and negative 2, we're at 4 and 0, which means instead of being a 2, I went up by 2 to 4, which means I have a C value of 2. Hence explaining this plus 2 over here. So it's a lot of steps. You just have to want to break down your important stuff. Break down your maxes, break down your minimums, break down any kind of shift you're seeing that's different from the norm. So you need to be able to understand what the normal sine graph looks like to be able to do that. Okay? I hope this has answered any and all of your questions, and please have a great day.